During this presentation, I hope to convince you to avoid using dense text to the degree possible, and instead to rely upon relevant graphics to support your final presentation. And it's all tied to the Space Shuttle program. Let me explain. In January of 2003, the Columbia Space Shuttle was launched for a 12-day mission devoted entirely to education and science experiments. With 7 astronauts aboard, scheduled experiments including 6 experiments designed by students from around the world under the STARS program. The payload commander, Michael Anderson, was responsible for managing the nearly 80 experiments on board, and everything went great during orbit. But re-entry into the Earth's atmosphere did not fare so well.
Columbia, Houston, UHF comm check.
Capcom, Charlie Hobart calling Columbia on UHF frequency as it approaches the Merritt Island tracking station range in Florida.
Columbia, Houston, UHF comm check.
During the shuttle's liftoff, NASA engineers noticed that a small piece of foam had dislodged and hit the shuttle's wing. This was nothing new. It had happened on several previous missions. But NASA engineers were concerned enough to request of management that satellite imagery be acquired to survey any possible damage to the wing. However, NASA managers chose to rely upon Boeing engineers' analysis of the situation. Boeing presented their reasoning in the form of 28 PowerPoint slides, and their conclusion? A safe return was indicated, even with significant tail loss. So what went wrong? An initial simulated test with the model wing left only a scratch on the material, but with the help of data recovered from the shuttle itself and enhanced video of the winged strike, a second simulation firing a comparable piece of foam at the calculated 600 miles per hour resulted in a devastatingly different result. So what does this all have to do with PowerPoint? While Boeing engineers verbally relayed their conclusion to NASA that their confidence was high that there would be no problems, the data was shared in text using those 28 PowerPoint slides. And more than one person has suggested that the density of information in the slides, along with the fact that many of the most important details were buried in the PowerPoint outline 2 and 3 levels deep, contributed to the lack of clarity about the risk at hand. Edward Tufte, who's best known for his work with visualization of scientific information, suggests there is a cognitive style to PowerPoint that obscures the message inside of outlines that give equal weight to information with varying importance. So let's apply some of his conclusions to your presentation. Here's a slide that might be as dense as something in your presentation if it's based on data you're collecting. There's a lot of information and it's difficult to see what's important. In this particular case, the presenter is talking about the number of short tons of steel used in automotive manufacturing during certain years. If you're lucky, the presenter might highlight the specific information rather than use an unsteady laser pointer. But even with that visual clue, you're likely to hear the time-honored phrase, "I know you can't read this, but what I'm showing you is..." This graphic is of little use and can result in what is lovingly called death by PowerPoint. And we're not just talking about charts. You've probably seen a bullet presentation that looks similar to this. Obviously, the presenter is using the slide to remember what to say. However, if information in your presentation must be read, it's much better to distribute handouts to your audience. So does this mean that you need to quit using PowerPoint and computers for presentations? Not at all. What I'm suggesting is an oral presentation is about you, the presenter, and what you bring to the experience, and that slides should only complement what you're saying. Before you place anything on a slide, you should ask yourself 2 questions. What's my point, and why does it matter? If you can't answer those 2 questions about anything you're going to show your audience, the information doesn't belong on a slide. So my point is that simplicity in visuals communicates. And the reason it matters is that you actually do want your audience to attend to and to understand what you're saying. In psychology, we often refer to the difficulty of extracting information from a slide as the amount of cognitive load placed on the viewer. That is, how hard is it to understand what's on the screen in relation to what the speaker's saying? If the graphic is at odds with the spoken word, or if it's irrelevant to what's being presented, it's a distraction. The audience has to spend cognitive time and effort figuring out what's on the graphic and why is it there, then reconcile the graphic with what you're saying. Something will be missed. And if the main points of your presentation are missed, the presentation itself will be unmemorable. So what makes a presentation memorable? Well, memory can be divided into two types, working memory and long-term memory. Working memory is that small bit of information we store in our brains as we're attending to our environment, to the presenter, to the graphics. If a spoken presentation is complemented by reinforcing graphics and the message is of interest to the audience, the experience will be transferred to long-term memory. When we say a presentation is memorable, it means that we are able to recall it at a later date, thanks to our long-term memory. However, experiences do not get into long-term memory unless you, as the presenter, facilitate the easy understanding of your main points. And that's exactly our goal here, to help you make your point in a memorable way. Let's go back for a minute to cognitive load theory. We can identify 3 different types of cognitive load associated with presentations. That is, 3 things that can make the main points of your presentation difficult to understand. Intrinsic cognitive load is the inherent difficulty of the topic. Understanding the human genome is simply more difficult than understanding how to make a salad. Can you, as a presenter, control intrinsic cognitive load? Well, to some degree, if you're very talented at taking your audience from point A to point B based on their pre-existing knowledge. But it can be difficult. Germane cognitive load refers to whether or not the audience is even interested in your topic. Can you as a presenter control germane cognitive load? Again, possibly. If you're entertaining and interesting, maybe you could get me interested in knitting. The final type of cognitive load is called extrinsic, as it is unrelated to the topic. It refers to the degree of confusion introduced by extraneous factors such as slide complexity. And this you can always control. And if you don't control it, cognitive load can become cognitive overload. So, how does one control extrinsic cognitive load? Well, the software itself is not the problem. There's nothing inherently wrong with PowerPoint or Keynote. I think the problem is SDTs. Now, this may not be what you're thinking. As in my world, SDT means slide distraction time, or the amount of time the audience spends figuring out the point of your slide before returning their attention to what you're saying. If what a presenter is talking about doesn't seem to be complemented by what's on the screen, there's a dissonance, a confusion that's created. And this is the face of slide distraction time. One way to minimize slide distraction is to use the exact same words you're saying verbally within the graphic. Look at this slide. If I'm saying the pituitary gland is nestled within Turk's saddle, anyone who does not know that Scylla turcica, or however it's pronounced, is a synonym for Turk's saddle, may be quite confused by this slide. However, if I label the slide to match my oral presentation, it doesn't take the audience long to get the point. This depression, called Turk's saddle, holds the pituitary gland. This is referred to as hear-see congruity. Secondly, whenever you have the inclination to put words on the screen, stop and see if you can come up with a graphic that gets the point across. Pictures are understood differently than words. They're much quicker to get and take less cognitive effort away from you, the presenter. For instance, let's go back to this lovely slide. It's talking about the number of short tons of steel used between certain years. Why not simplify the information by taking 10 minutes to find a relevant background and to extract the data in a simplified form? However, not all slides are this simple. So when you're trying to explain complex concepts, there's another approach you can employ to simplify slides. Here I've got respiratory epithelium and 3 types of cells. Now I could use a laser pointer to indicate the 3 types of cells, but there are other things going on here. For instance, what's the G letter stand for on the cell? Nothing in our side text starts with G. The first thing I suggest, before we get into the details of the legend, is to make the slide more readable. You can start by using non-serif fonts. If you look at the small r in the word respiratory, you can see that the horizontal curve of the letter starts with a thin stroke and gets thicker. This is called a serif. Serif fonts are likely easier to read on the printed page. However, your presentation will be captured on video, and serif fonts do not capture well on video. The thin stroke can create a moire pattern and start to shimmer. So to make this slide more readable, start by using a non-serif font like Arial, Helvetica, or Verdana. The next thing this slide needs is an explicit legend. Who would have known that G stands for mucus-secreting goblet cell? That legend, however, is better placed closer to the letters so that the audience doesn't have to scan back and forth and keep track of the relationship between legend and letters. In cognitive load theory, this is called contiguity. Place descriptions of objects as close to the object as possible. In fact, I've done two things here. I've placed the legend closer to the objects, but I've also increased the contrast of the legend so it's easier to read. And while I'm at it, I've increased the contrast of the letters to make them easier to read. I might even tone down the background a bit to reduce glare. All of these suggestions help make the slide as readable as possible, but it doesn't solve the underlying problem. There's probably too much information at one time on the slide. So the technique I'm suggesting to you, when you have a complex concept, is to break it up and cumulatively reveal the information. In this sequence, I would first talk about cilia, then the ciliated columnar cells, the goblet cells, and finally basal cells. To the degree possible, don't have information on the screen that doesn't relate to what you're talking about at that minute. And this suggestion applies to type also. Although you're going to do your best to get away from long text slides, I'm sure. Use cumulative revelation for those slides that can't avoid text. First, break up the information into chunks, so only the stuff you're talking about is on the screen, not things you're going to talk about. Secondly, reduce long text to keywords to make your point. Your oral presentation will fill in the detail. And finally, cumulatively reveal the information as the topic comes up. A couple other suggestions about text on your slides. Use 28 point or greater so that the text will be clear during video capture. Again, use non-serif font to avoid shimmering letters. Don't use all caps, lots of underlines, or italics to excess. And avoid red fonts. When red is captured through an analog television camera, this is what it looks like, since the red tube's not very sensitive to the edges of the letters. A viewer watching your presentation streaming on the web would not be able to read your slide. And finally, a summary of suggestions. Use relevant graphics whenever possible and avoid text. Know your audience and what they know coming into the presentation and the knowledge holes you have to fill in to get them up to speed to understand your talk. Check out the room environment ahead of time. If the lighting's dim, light letters on a dark background can work fine. However, if sunlight is coming in, you're much better off using a light background with dark letters. Know your technical support person so you don't have to worry about the setup not working when it's show time. And finally, don't use gratuitous effects like I've done here. They may be cute the first time, but they get old quickly. In this presentation, I focused on the design of your slides, but there's another part of your presentation, your self-presentation. While we won't look in detail at suggestions for your delivery, there are some suggestions offered by those who have done TED Talks. First of all, you need to choose a topic because you're interested. If you're not, it'll be apparent to your audience. When you start your presentation, open with an attentionator. What's an attentionator? Well, it's a made-up word, but the point is to get the attention of your audience with something a bit controversial or unexpected. I tried to do that at the beginning when I said there was a relationship between PowerPoint and the Space Shuttle program. That should not have been expected. Where possible, use a conversational personal story as an example of where you're going to go with the talk, a story that the audience might be able to relate to. Throughout your presentation, focus on principles, not facts. It does no good to throw a bunch of data at your audience if you don't comment on what the takeaway point is. Look for the counterintuitive in those principles, things that surprised you about your research. I'll end with an excerpt from a TED Talk presentation by Hans Rosling. This is just the first couple of minutes of his presentation, but you'll see that he effectively employs all of these devices within those first minutes.
I'm going to talk about your mindset. Does your mindset correspond to my data set? If not, one or the other needs upgrading, isn't it? When I talk to my students about global issues, and I listen to them in the coffee break, they always talk about we and them. And when they come back into the lecture room, I ask them, what do you mean with we and them? Oh, it's very easy. It's the Western world and it's the developing world. They say. We learned it in college. And what is the definition there? Well, definition, everyone knows, they say. But then, I press them like this. So one girl said very cleverly, it's very easy. Western world is a long life in a small family, and developing world is a short life in a large family. And I like that definition because it enabled me to transfer their mindset into a data set. And here we have the data set. So you can see that what we have on this axis here is size of family, 1, 2, 3, 4, 5 children per woman on this axis. And here length of life, life expectancy, 30, 40, 50. Exactly what the student said was their concept about the world. And really this is about the bedroom, whether the man and woman decide to have small family and take care of their kids and how long they will live. It's about the bathroom and the kitchen. If you have soap, water and food, you can live long. And the students were right, wasn't they? The world consisted here of one set of countries over here, which had large families and short life, developing world. And they had one set of countries up there, which was the Western world. They had small families and long life. And you are going to see here the amazing thing that has happened in the world during my lifetime. And then the developing countries applied soap and water, vaccination, and all the developing world start to apply family planning, and partly to USAID, who helped provide the technical advice and investment. And you see all the world moves over to two-child family and a life with 60 to 70 years. But some countries remain back in this area here. And you can see we still have Afghanistan down here. We have Liberia, we have Congo. So we have countries living there. So the problem I have is that the worldview that my students have correspond to reality in the world the year their teachers were born.